Hey everyone, is the rest of the notes for lesson 2. So basically in the first part of lesson 2, we talked about transformations in the form of y equals a over x minus h plus k. So how to determine those from the pre-image to image. Today with this, we're going to be talking about how do we graph rational functions. Now I know we've already graphed with y equals a over x minus h plus k, but now we're going to talk about, well, how do we graph it in a different form? Okay, first, let's look at example 5. It says rewrite g of x equals 4x over x minus 3 using long division. So what I would like you guys to do is go ahead and pause the video, because long division is a review here. Pause the video and go ahead and use long division on this rational function here. Okay, let's see how you did. Okay, so remember how we use long division. X minus 3 is going to be on the outside, and then the 4x is going to be in the inside here. Okay, so remember, the idea is that we want to match this first term. We have to think, well, 4x plus what, or sorry, we have to think x times what gives us this 4x. Now, in this case, we kind of really don't need to do this, but I will do it. Notice we do not have a constant, so I'm going to do a plus 0 here because we may have to do something in regards with this, but just in case. Okay, so as stated, we need to determine x times what gives us 4x. Okay, well, in that question mark, it's going to be a 4. So that's our first thing, to match the first term. Remember, next, we're going to take our 4 and multiply it by every term on the outside. So 4 times x is 4x, and 4 times negative 3 is minus 12. Okay, next, third step is to combine the two polynomials here. Now remember, we are subtracting. Now what I'm going to do is actually change this to a plus, but change all the signs inside. Now remember, these two terms should cancel out. Boom. Okay. So then from here, I do 0 plus 12. And now we can see that, well, I can't multiply x by anything to give us 12. So this is our remainder. Now, let's kind of talk about how we write this. Okay, so we have g of x equals, so 4 was our polynomial, and then we take, remember, the remainder and put it over our x minus 3. Now, this form may look familiar because when we did first part of lesson 2 and really the end of lesson 1, we talked about graphing functions in the form of y equals a over x minus h plus k. So let me kind of rewrite that a little bit in this form here. So I have g of x. So this a over x minus h, well, that's actually the remainder over x minus 3. And then our k value in this case is 4. So what this indicates is that basically this is a different form of a rational function, which we're going to see later on and how to graph it, but we can change this form into a form we have already seen using transformations in regards to our a, h, and k values. Okay, so now let's talk about rational functions. We've seen the reciprocal function. We've seen it in the rational function as y equals a over x minus h plus k. Another form is where we have two polynomials. Okay, so p of x and q of x. Just like in the last example, we had g of x equals 4x. Well, 4x is a polynomial, that's linear, and then x minus 3. Once again, x minus 3 is a polynomial, it's linear. Okay, but what we can do is go from this form and rewrite it in a different form if we need to. And we can do that using long division. Okay, now let's talk about how do we graph in this form where we have a polynomial over a polynomial. So we have the form of ax plus b over cx plus d. So we kind of look at basically in regards to here and our ax plus b over cx plus d. Notice that our 4 here is the a value, okay? And then we kind of just look in this form here. It kind of changes a little bit in regards to that, all right? Okay, so now do this so you can kind of just see how we can change it into this form. So we got 12 over x minus 3 plus 4. Okay, so now, once again, let's talk about how we graph it. So let's talk about how do we figure out the horizontal asymptote. Well, that's going to be y equals a over c. Okay, so whatever that a over c is there. Vertical asymptote is just like we did it in the other form. You set the denominator equal to 0. Okay. Now, I do want to talk about this horizontal, how this relates to our other form. So in our last example, we had y equals 4x over x minus 3, and we changed it to that y equals 12 over x minus 3 plus k. Oops, plus 4, excuse me. Now, when we talked about horizontal asymptote here, we said it's y equals the k value. In this case, the horizontal asymptote is y equals a over c. So we look, 4 in this form is our k value. And if we actually look here, a over c, so we look at a over c, a is the top, c is the coefficient in front of this x, so that 4 divided by 1. So you should get, no matter which form it is, you get the same exact vertical and horizontal asymptotes. The reason being, it's the same function, okay? We're just writing it in different ways. So just wanted to show you that connection there. Okay, let's go to example 6. So it says graph at least 4 points and label the asymptotes. Now, the process that we used in this a over x minus h plus k form to graph that, we're going to use the same process. So the first thing we need to do is identify the vertical and horizontal asymptotes. So remember, horizontal is a over c. So if we look at example 6, we have 2x plus 1 over x minus 3. Notice that our a value is 2 and the c value is 1. So we have 2 over 1. That just gives us 2. So our horizontal asymptote is y equals 2. Now, vertical asymptote, just as we did before, we set the denominator equal to 0. We have x minus 3 equal to 0. We solve, so x will equal 3. Let's go ahead and draw our asymptotes here. So y equals 2, that's horizontal. And don't forget, as is stated, label, so I have to do y equals 2, and then x equals 3. Okay, next step is to do the XY table. Now, just like we did before, we're going to place the vertical asymptote in the middle because this allows us to pick 2 points that are on the right-hand side of the vertical asymptote, so values bigger, and then 2 x values that are on the left-hand side, so 2 values that are smaller. So 2 values smaller are 2 and 1, maybe bigger can be 4 and 5. And once again, we're going to plug these values into our function, 2x plus 1 over x minus 3. Now, let me show you how you can use your calculator to help you. Okay, so let's try 1 for this. So if you're using a graphing calculator, you can use the fraction. So we do alpha y equals using the fraction key here to do this. So we have 2. Now, in the x, I'm going to place the value, our x value is 1. And then plus 1. And then the denominator, we do also the 1. So there's multiple places you're going to have to do this. We press enter, and we get negative 3 halves. Okay, now let's say you don't have a scientific or somehow your scientific is a little bit older. You can do this with parentheses. So because there's multiple terms in both the numerator and denominator, I have to use parentheses here. So I could do 2 times. I'm going to try the next x value, which is 2. So then another parentheses to finish that off, then plus 1. And then do divided by, and then this will just be 2 minus 3. That gives us negative 5. And if you'd use the fraction key, you get the same answer. Okay, and then we try 4. So here you can do a little bit mental math as well if you're able to. So 2 times 4 is 8 plus 1, so that's 9 in the numerator. And then 4 minus 3 is 1. So basically 9 divided by 1 is 9. Okay, last one, we plug 5. So 5 times 2 is 10 plus 1 is 11. And then plug it in, 5 minus 3 is 2, so we get 11/2. So let's go ahead and plot those points now. So we have 1, 2, 3 here, and then 2, -5. So 1, 2, 3, 4, 5. And remember, basically, these points or this part of the function is approaching the two asymptotes. Okay, the other one's 4, 9. And then 11/2 is 5.5. So that's 1, 2, 3, 4, 5. And there we go. Okay, so after we graphed, our last thing we need to do is do domain and range. Remember, domain is affected by the vertical asymptote. So basically, this is indicating that all x values work except for that vertical asymptote. And then the range is affected by the horizontal asymptote. Same idea. So we have all y values except for whatever that horizontal asymptote is. Okay. So now let's just try one more example so you guys can practice a little bit more. So what I would like you guys to do is pause the video and try example 7 on your own. So here is example 7. Okay, so horizontal asymptote. Remember, we do our A over C. So the numbers in front of our x's, they're both 1. So 1 divided by 1 is just 1. So our horizontal asymptote is y equals 1. Vertical asymptote, remember you set the denominator equal to 0. So x minus 2 equals 0. And then move the 2 over, x equals 2. Then I did my xy table. Remember, just plug this you can into your calculator. You can do some mental math as well. And then here's the domain and range. So remember that domain is affected by your vertical asymptote. So it's all numbers, all real numbers, except for that vertical asymptote. And the range is going to be affected by the horizontal asymptote. Okay. Okay, well, let me know if you have any questions. See you guys later.